Take out your highlighter. Does it make sense that when you have the absolute value of a parabola, that it's possible that it could have 0, 1, 2, 3, or 4 solutions? For example, here I have the absolute value of a parabola. It makes that W shape sometimes, depending on where the parabola is. If the parabola is all above the x-axis, the absolute value won't do anything to it. But if part of the parabola is below, when you do the absolute value, you get a graph that looks like this W. Can you see that if you drew a line here at -3, there would be no solutions? Does that make sense? Can you see that if you drew a line there, there would be 2 solutions? You could draw a line right there, and there would be 4 places that it intersects to give you 4 solutions. And if you happen to draw it right where the vertex was, you could have 3 solutions. In some cases, if your original parabola just touched the x-axis, there is a possibility that you could have only 1 solution. What we're going to do next is we're going to look at how do we solve these equations algebraically, because that's not always the most fun to graph everything out. So if we go to example 3, it says solve this equation algebraically. Okay? When solving there are always 2 equations to solving when solving an absolute value equation. Why are there 2 equations? Well, the 4x plus 6, depending on what number you plug in for x, is sometimes positive and sometimes negative. For example, if I plug in x is 3, 4x plus 6 is 18. Do the absolute values matter? No. If it's a positive number, you could just get rid of the absolute values. But if it's a negative number, for example, if I plug in -5 for x, 4 times -5 is -20. Plus 6 would be -14. And what do the absolute values do? Make it positive. Turn it to positive, right? So we don't know if the inside of the 4x plus 6 is positive or negative. But we can do this. If 4x plus 6 is bigger than 0, do the absolute value bars, do they need to be there? No. Because if it's positive, the number stays the same. So if 4x plus 6 is bigger than 0, then x plus 8 equals 4x plus 6. And you change it back into a grade 9 question for solving. Right? How do I solve 4x plus 6 equals x plus 8? Well, I put my like terms together, bring the 6 to this side, bring the x to that side. And it's possible that x could be 2/3. If 4x plus 6 is less than 0, then you would have x plus 8 equals, what would the absolute value do to the 4x plus 6 if it was less than 0? It would multiply it by a negative to make it positive. So we show that algebraically by putting a negative in front. If the 4x plus 6 is negative, the absolute value makes it positive by multiplying by -1. That's another way you can make a negative number positive. If you had negative 3 and you multiplied it by negative 1, it would become positive 3. And we do the same thing here. You distribute the negative. Put your like terms together. So I'll move my x's to this side, subtract 8. And I get x is equal to negative 14 over 5. Sometimes with absolute value equations, the answer you get isn't actually an answer. So with all of your solutions, and this is a little bit different technique than the textbook uses, I find it's easier just to verify in the end. Does 2/3 work? So you take your left side of your equation and your right side of the equation, your original equation, which in this case was x plus 8. So does 2/3 plus 8, the right-hand side of my equation was 4x plus 6. Does it work? How do I add fractions? Get a common denominator. This side will be 26 over 3. This side will be 8 over 3 plus 18 over 3. Absolute value of 26 over 3, which is 26 over 3. Those answers are the same. So x equals 2/3 works. It's one of our solutions. Verify x equals negative 14 over 5. Your left side and your right side. Your left side is x plus 8. Your right side was 4 times x plus 6. Again, how do we add fractions? Common denominator. This side is 26 over 5. And here, oops, not. If both the left side and the right side simplify to be the same thing, then you know the answer works. If they simplify to be different numbers, sometimes only one works, and sometimes you get a situation where neither of them works. Then you would say no solution. But you'd have to do all this work to verify to find out there was no solution. Of course, that's why I'm just for you. Now, as far as techniques go, on your exam, you're going to see more of these solving algebraically than you will see solving graphically. So I'd like you to try question number 8 right now.